Linear regression modeling and its applications. For this presentation, I use interpretation of concrete dam behavior with artificial neural networks and multiple linear regression models. A linear regression model creates a relationship between two parameters, x and y. It is shown by the formula for a line y equals mx plus b, where b is the y-intercept, or the proportion of the data that is explained when there is no x variable, and mx, which is the slope and explains how each unit of x increases or decreases y. The more correlated the data, the stronger the model will be. On the right, you can see the relationship between weight versus strength. A model was created and shows a positive slope. Most of the data points are close to the linear model. A poor linear model is shown on the right. The linear model approaches the mean of the y variable and is almost horizontal. Each increase in x has very little effect on the y variable. You can call this difference from the model to the actual point an error. Each plot has its own random error, and it exists in most real-world models. The implementation of a linear regression model involves you plotting each point in a data set, x and y. With these plots, you will then be able to find the mean and eventually the linear regression model estimate as seen by the green line. This green line is the line of best fit. This means that the total distance from all points is minimized by this line. The error of this model is shown by the distance from any point to the linear regression line. When creating this model, you will want to first look for outliers, as any major outliers can cause huge differences in either the y-intercept or the slope. In the bottom right corner of this picture, you can see an outlier. You also want to look for patterns and make sure that your data looks linear. If not, there may be a better model to predict the outcome. The research paper I examined used multiple linear regression models to analyze the safety of a dam. A multiple regression model is built upon linear regression and is many-to-one relationship. It has multiple independent variables that affect one dependent. Using too many variables can cause overfitting, which is caused by multicollinearity. In the research paper, the dam used three different variables: temperature, time, and pressure. These three variables produce a very strong prediction, as you can see by the graph on the right. The applications for this approach can be seen in timing maintenance and finding the safety factor of the dam at any given point. Though linear regression models are not perfect, they're very powerful tools for predicting something within a certain area. Constructing linear regression models correctly can lead to many cost savings and safety improvements.